If you remember, we had repaired this unit before, and it was showing an F6 error. However, now the error has changed. When we turn it on, let's observe what issue is occurring. We switched on the power, and the circuit board switched on. The outdoor unit started running, and at 16 degrees, the indoor unit is functioning properly. Its fan motor is also running. Now, we need to check what happens when the compressor tries to start. Once we understand this fault, we will be able to repair it. Now, if we observe its LED one, it is stable with no fluctuations. However, we need to keep an eye on the analyzer because it will reveal the complete story of what is happening. Let's observe. The outdoor fan motor started. And here you saw that all these IGBTs turned on and then turned off. A slight sound came from the compressor, and along with that, you can see here, LED 1 started blinking. If we count the blinks, 1, 2, 3, 4, it blinks 4 times. I have left the unit running continuously so that it can display an error. Once the error appears, it will make troubleshooting easier because I will only need to focus on a specific area. However, if no error shows up, then we will have to check the entire PCB. Now, after 6 to 7 attempts, the system detects a fault, and as you can see on the display, it is showing an E4 error. What does the E4 error indicate? As you observed, the system is trying to start the compressor, but the compressor is not starting. This means the error is related to abnormal compressor starting. Since the compressor is failing to start, we now need to inspect the PCB to find out what fault is preventing the compressor from turning on. Let's proceed with the diagnosis and check where the issue lies. As I mentioned earlier, someone had already attempted to repair this PCB, and work had been done on both the indoor and outdoor sections. However, when the repair was unsuccessful, they removed the IPM module to inspect it. Now, we need to test the IPM to determine whether it is functioning properly or if there is a fault. Apart from this, the rest of the system seems to be working fine. It is trying to start, but the compressor is not taking a startup. To check the IPM, we will use a multimeter in diode mode. Based on my experience from testing IPMs in many videos, if we place the positive probe on the positive terminal and the negative probe on the negative terminal, there should be no short circuit or any abnormal reading. If the multimeter displays 00, then the IPM could be faulty. Now, after switching the probes, the voltage drop is showing 0.535 V, which is within the expected range. At the next test point, the reading is 0.404 V, and the values for V phase and U phase are also the same. This suggests that the IPM is not shorted, but further analysis is needed to confirm if it is fully functional or if another issue is preventing the compressor from starting. Now, under normal conditions without electricity, the IPM appears to be fine. However, sometimes a problem only becomes evident when power is applied. So, let's test it under electric load to confirm whether it is functioning properly. I am now supplying power to the unit, and the outdoor unit has turned on. Next, I will use a multimeter in DC voltage mode to check the readings. Placing the positive probe on the positive terminal and the negative probe on the negative terminal, the voltage reading is 310.6 VDC. Checking at W phase, the reading is 15.34 V. At V phase, the reading is 15.28 volts DC, and same at the U phase. However, at all points, the voltage appears normal, and no abnormality is detected in the IPM voltage readings. Now, I will turn off the power and proceed with the next steps. I have observed that this PCB has already been worked on, and specifically, someone has worked on the IPM. I suspect that the IPM has been replaced, possibly because the original one was faulty. Since all other functions are working properly, but the compressor is not starting, I will now proceed with removing the IPM to inspect it further. To do this, I will place a holder beneath the IPM to support it. Next, I will add a small amount of solder to the existing joints. The advantage of adding solder is that it will help the IPM heat up evenly, and the joints will stay warm for a longer period. This will make it easier to remove the IPM. Now, I will use both a hot air gun and a soldering iron simultaneously. The IPM will only come off once a specific temperature is reached, so precise heating is necessary. Once removed, I will clean the holes thoroughly. A good suction tool will help in clearing out excess solder. Now that the holes are almost cleaned, I will use petrol to clean the area properly. Thorough cleaning is crucial because if any pin or PCB print is damaged, it will become visible after cleaning. Pins have been inserted from this side. And here you go. We have installed the new IPM. I have replaced the IPM, but there is still a problem. Let me explain what's happening. After installing the new IPM, I tested the PCB, but it is still not working and continues to show the same E4 error. Even though the IPM is new, there seems to be an issue with it. Before installation, I tested the IPM in diode mode to ensure there were no faults, and at that time, it appeared to be completely fine. Now, let's check it again. I placed the negative probe on the negative terminal and the positive probe on the positive terminal. A brief voltage drop appeared and then disappeared. No voltage drop is visible on U, V, or W phases, which indicates that the IPM should be working properly. Next, I reversed the polarity, and the voltage drop measured 0.546 V, which is approximately correct. Further checking showed 0.443 V, and the remaining 2 points had the same values. So, when tested using a multimeter, the IPM appears to be perfectly fine. But what happens when I apply power? Now, I am supplying direct power to the PCB without connecting it to the indoor unit to observe its behavior. The PCB turns on successfully. The green LED starts glowing. The red LED is also functioning. Switching is taking place, meaning the circuit is responding. However, despite these normal indications, the compressor still does not start, which means the issue is still unresolved. I will now investigate further to pinpoint the exact cause of the fault. As we know, certain voltages should be present on the IPM when measured. I placed the positive probe on the positive terminal and the negative probe on the negative terminal, and I am getting 312 V DC, which is correct. Now, when I check at the W phase, it should show around 15 V, but instead, I am getting the same voltage on U, V, and W phases. This indicates that the IPM itself is faulty, even though it is new. Despite being replaced, it is still causing problems. This confirms that the IPM is not functioning correctly, which is why the compressor is not starting, and the E4 error persists. Off camera, I have now installed the new IPM onto the PCB, and it's time to test whether the PCB is functioning properly. Now, as you can see, I have installed all the components, reattached both the indoor and outdoor units, and ensured everything is properly connected. I am now turning on the power. The indoor unit has powered on. The outdoor unit's red light has turned on. You can see that the indoor unit has started at 16 degrees, and the fan motor is running. We will wait for a few moments. Now, the relay has switched on. At the same time, the compressor has started. You may have heard the compressor starting sound. Since the gas system is not connected, we won't keep it running for too long. However, the unit is now fully functional, and the issue has been successfully resolved. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.